And welcome to SanfordFlipMath. We are working through the PreCalculus course, and again we are working from the Demana Waits Foley Kennedy book, 4th or 5th edition, depending on which book you have. And we are in Chapter 4, spending a lot of time on Section 4.4. The first big chunks of this section were about graphing sine and cosine functions. The next section is really about solving sine and cosine equations, a little bit of tangent equations thrown in just for fun, because the process is really the same. So sine of x equals 3/4 is an example, and just so you're aware of how we've handled this before, the basic process is we're going to do inverse sine of each side, and when we do this we're left with x equals inverse sine of 3/4. So x equals, well, inverse sine of 3/4. Well, look at all of that. That's just kind of a mess, isn't it? So inverse sine of 3/4. And well, what is that? That's not what we had before. Okay, well, we're going to do that in just a second, but just so we're working with something a little bit more familiar. Inverse sine of 3/4. 48.590. 48.590. 48.590. Okay, well, I have a little question for you. First of all, how did we know that we were in degrees? Now, for instance, if I go back to working with just regular old triangles like we had before, okay, just for a quick little trip down memory lane back in section 4.2, if this was my angle and this was 3 and this is 4, I might say sine of theta is 3/4, and so theta I would do inverse sine just like I did, and it's 48.590 degrees. Great. Okay, so that's fine, but what happens if instead what we're looking at is something like this? Oh, Mr. Sanford, you're just doing too much now. Okay, so here's my 48.990. Well, what's to say that that's where it was? I mean, maybe it was over here. And if it's over here, then really the angle isn't 48.590. The angle's really 180 minus 48.590. Whatever that is. Okay, so 131 point, I guess that's 41. So maybe I have that solution, maybe I have that solution. Maybe I could go around again and say, if I know some of you are looking at me like, why are you making this so hard? Okay, well, here's my issue. I don't know which solutions there are that they want. Okay? All this says is solve. Okay, so let me do this. We're going to do the same problem again, and we're going to do much of what we just did, but I'm going to tighten it up a little bit for you. Okay, so here we go. I'm going to tell you that I want to know the solutions for this between 0 and 360. So what that means is I want all of the solutions between 0 and 360. Okay, so this gives us a different focus. Okay, process-wise, we're going to do some of the same stuff we just did, but here's the issue. I need you to notice that this says a positive 3/4. So as I'm thinking about where is sine positive, all students take calculus. Okay, I'm using my little mnemonic. Okay, so sine is positive here, sine is positive here. So I'm going to draw a triangle here, I'm going to draw a triangle here. That means I'm going to have two triangles. This says one full time around, anything from 0 to 360. I don't have to worry about quadrants 3 and 4 because sine is not positive down there, sine's negative down there, so I can ignore those. So I'm going to have two solutions. Okay, let me tell you right now that most trig equations, if you're talking from 0 to 2 pi or 0 to 360, are going to have two solutions. Okay, there will be some specific situations that won't, like if we're talking about quadrantal angles here and there. So, the ones on an axis. Okay, most of the time, two solutions. Normally, not always, normally your calculator will give you the reference angle. So for cosine, sometimes you have to do a little work to get the reference angle. So we'll see that happen at some point. Okay, so let's go back to what we did just a second ago. Okay, we did inverse sine. Okay, and that was all of this. Okay, so let me just grab that. We don't really need to redo it. And we'll just paste it right in there. How about that? Sneaky Mr. Sanford. Okay, so I just did inverse sine so that I could get the angle. Okay, now just a quick reminder that 48.590 was right there. That's the reference angle. That is one of the solutions. It is a first quadrant angle, and I expect a first quadrant angle to be a solution for this. Okay, if I take that 48.590 degrees and put it here, then that means I could rotate here to do that. Now, just a reminder that to get rotational angles, you're never ever doing anything with 90 or 270. Okay, so I'm not going to say 90 plus 48, because that 48 is the angle to the x-axis. The x-axis is at 0 or 180 or 360 or something like that. You know, I might keep going even. Okay, but it's never about 90 or 270 because that's the y-axis. Reference angles are made with the x-axis. Now the thought is if I rotate all the way to the x-axis, that'd be 180. I have to back up 48 degrees. Okay, so I got to do 180 minus 48.590 degrees. Okay, and this will be another value for x. Okay, so 180 minus 48.59. So 180 minus my answer, 131.4096. Well, that 96 is going to, 4096 is going to make that 410. So 131.410. 131.410. Okay, so those are my two solutions, and I'm done. That's it. So I did inverse sine, and then I had to deal with the issue of what about the other quadrant. Okay, well, this is really an Algebra 2 problem. Okay, I know, you know, for many of you this is not very fun, even in pre-calc, but one of the things that sets apart pre-calc here at our school is that we really, you know, we don't just dabble in radians, we start working in radians. So I want to do this again. Now look at the problem. Sine of x equals 3/4, 0 to 360. Sine of x equals 3/4, 0 to 2 pi. Is that the same thing? Yep, pretty much. It's just not in degrees, it's in radians. So I want to do the same exact problem again, only in radians. Okay, so thought process, the same. 3/4 is positive. Again, sine, cosine, the sine is positive. Okay, and I don't want to retrace my steps completely, but so we're going to be in one of those two quadrants. Okay, so here it is. And again, I'm going to do inverse sine. I'm doing the inverse sine of both sides of 3/4. Okay, so I'm going to type this in again. Okay, the only catch is I'm going to do this in radians. Okay. Now I know some of you are asking this question already, but I'm not going to say it yet. I'm just going to roll with what I got going here, and I'll answer that question on the next, in just after I'm done with this problem. Okay. So inverse sine 3/4. Enter. 0.8480. 0.8480. I want 3 decimal places. That's what I'm standard. 0.8480. 0.8480. All right, I need 3 decimal places. I'm good. Okay. Well, what did we just find? That was the reference angle. Now, here's a question for you. How do I know, reference angles, quick little aside here, are supposed to be between 0 and 90. They're supposed to be with the x-axis. And Mr. Sanford, and positive. Now, positive's kind of already in the 0 to 90 thing, but I always like to emphasize it. Now, Mr. Sanford, you said the calculator normally gives you the reference angle anyway, so I can kind of be confident that that's the reference angle, right? Well, I guess so. But just to be sure, in radians, 90 degrees is pi over 2. So my question is what's pi over 2 as a number? Well, take 3.14 and divide it by 2. So is 0.848 between 0 and 1.57? And that answer is a resounding yes. So sweet. Okay, I just want to be sure because I know right now we don't have a lot of comfort with radians, and so you need to kind of get more comfortable with it. You know, you need to have a little bit of number sense that goes with that. Okay, now how then do I get this rotational angle? And again, the concept is the same. If I rotated all the way to the x-axis, that'd be 180, and I got to back up 0.848. Now, I have a little bit of problem with what I just said though, because I'm kind of mixing units. I said 180, and this is not degrees. This is supposed to be radians. So really, it needs to be pi minus 0.848. So x equals, so pi minus 0.848, pi minus my last answer. So 2.2935, I'm going to call that 294. So 2.294. 2.294. Okay, and that's it. So we just did the same exact problem, and think about process. We did the same exact thing. We did inverse of the trig function of whatever that number was, and then we did 180 minus, or pi minus. If I'm in radians, I'm doing pi. If I'm doing in degrees, I'm doing 180. Okay. Now, if I was in a different quadrant, I might be doing 360 instead. Okay, so let me go back and answer that other question that I heard so many of you asking. If I was doing this problem, couldn't I just do this problem and convert? And the answer is yes. So some of you, okay, let me see if I can just kind of grab all of that, copy it. Let me take it over here for just a minute. It's going to put it in some funky spot. Okay, and let me grab it and pull it down here. Okay, some of you would rather take this, you know, do the whole problem in degrees, and then just say, you know what, times pi over 180, times pi over 180. Well, you know what, you can do that. Now, my advice is don't do that with a bunch of rounded answers. I'm going to do it with a bunch of rounded answers right now. 48,590. Whoop. 90 times pi over 180. 0.848. Wow. 0.848. Wow, that sounds very familiar. I don't know. Let's see. 131,410. 131.410 times pi over 180. See, this converting thing is cake, right? 2.294. 2.294. So the question is, can I do this in degrees first and then convert after? Well, 0.48, 848, 848, 0.2. So the answer is yes, you certainly can. Okay. All right. Well, that was exciting. Now let's up the ante just one more. What the heck does that mean? That means not only do I want the two different quadrants, I want all of the coterminal angles as well. In other words, not only do I want 48.590, okay, you know what, let me just keep this, let me take that over here and see if I can just, I think that was the last thing I did. Yes, life is good, Mr. Sanford. Okay, so when I did the two different quadrants, this is what I got. Now, what if, so here's that 48-degree angle. What if instead I spun around 360 and then added 48.590? What if I spun around 2 times to 720 plus 48.590? What if I spun around, you guessed it, 1, 2, 3 times, 4 times, 5 times, 6 times, lots of times, and then added 48.590. I'd still end up there. They're all coterminal angles. And if I do the sine of any of them, when I do the sine of 408.590, I'm going to get 0.75, 3/4. So I can add any multiple of 360 on and still get the same sine value. These are all solutions. Now people don't like this, okay? The idea here is k represents an integer. You don't have to write that part, but you do have to write everything that's in this box for this problem. K is an integer, in other words, a whole number, positive or negative or even 0. So it's any multiple of 360. Well, that's great, Mr. Sanford, but that didn't answer the question about the other quadrant, because none of these angles end up in the second quadrant. They all end up in that first quadrant. Well, right you are, and so the second quadrant is handled with this one in the exact same way. Okay, so there it is. Okay, all right, so this is if x was in all real numbers. Now, this is assuming that it's in degrees. Okay, so let me just do one more thing with this same exact problem, and let me grab these. So if this problem specified all real solutions in radians, oh, that's bad. Okay, so let me do it again. In radians, here we go, good, that's much better. Then it would be handled exactly the same way. It's just instead of adding 360, okay, so that's it. So if it said all real numbers, now most of the time they specify a quadrant or the first revolution or maybe a couple of quadrants. You just have to think about what quadrants are they asking for, okay? All right, I want to do just one more, and I know time is tight. Let's do one with tangent, and so tangent of x equals, we'll stick with 3/4. Let's do negative 3/4, just so we have different quadrants to work with, okay? All right, so where am I going to draw my triangles? Where am I going to put this thing? Okay, so this is a good spot to stop the tape, stop the recording, and just try and do this on your own, because the process is the same. Tangent doesn't matter. The only thing that makes a difference is what quadrants you're in. Okay, all right. So you pause. I'm going to keep going, and then you do your thing and see if what I do matches what you do. Okay. All right. Here we go. All right. So I'm going to make some quick notations here. All students take calculus as my mnemonic. I know tangent is positive in this quadrant and this quadrant, in the first and third, so that means it must be negative in the second and in the fourth. Okay. Now, the process is the same as I said. I'm going to take the inverse tangent of both sides. That cancels that out. Inverse tangent here. So x is the inverse tangent of negative 3/4. Now, quick little note here. I forgot to tell you what range of values, what domain to work with it. So I'm going to just say from x is 0 to 2 pi, because that's kind of the common one, either 2 pi or 360. So please note that this, since I have specified 2 pi, this is going to force this to be in radians. Now again, you can do this in degrees and then convert. I think it's more work. But I know that the comfort levels are going to be different throughout the classes. So, some of you are just going to, no matter what I say, you're going to do it in degrees every single time and then convert. Some of you are going to do it in degrees every single time and forget to convert. So, all right, inverse tangent. So, again, I'm going to do this in radians right out of the chute. Okay, so I'm in radians. Inverse tangent, negative 3/4. Okay, and that is my angle. Now, negative, 0.643 is between 0 and pi over 2, 0 and 1.57. So it is kind of a reference angle. The problem is that it's given me a fourth quadrant angle, kind of. 0.644, I'm going to call this. Okay, so, but it's telling me negative. So what it just said was negative 0.644. So this is really the angle it's telling me. Now, is negative 0.644 between 0 and 6.28, between 0 and 2 pi? I don't think so, because negative 0.644 is, you guessed it, negative. Okay, that doesn't work. Okay, so I can make this into a reference angle though, and just say 0.644 because that is how far we've rotated. Okay, so quick little note here, 0.644 and 0.644. Okay, so how far did we really rotate to get to here? Well, to get all the way to this axis would be 180, or pi. Back up 0.644. So the first one is going to be pi minus 0.644, and we'll do both of these in a second. The other one is going to come from 360 minus, or in other words 2 pi minus 0.644. Okay, so the reference angle wasn't one of the angles at all. Okay, so quick little note here, I'm going to do the negative of my answers so that I can just kind of follow what I just wrote. Okay, so one of them was pi minus that, so 2.498. This is the pi minus. Okay, I got to see it again, sorry. 2.498. 2.498. Okay, and then the other one is 2 pi minus. Okay, so 2 pi minus, okay, I'm going to cheat. Sorry, it's the beauty of having the new system. 5.6396, so 5.640, 5.640, 5.640. Okay, now for those of you that are just absolutely married to degrees, and no matter what I say, you're going to do degrees anyway, and even those that aren't, you know, you're like, okay, I'm game, I can do the radian thing. Just take a minute and do the problem again in degrees, and then convert and see if you actually get these same numbers. Okay, I'm out of time. I've gone beyond time, but we did like a lot of different stuff here to illustrate the different possibilities. So thanks for watching. Thanks for hanging. SanfordFlipMath. We're out.